one is, again, due this Friday. Where are you? If you're following along in the Gantt chart, where should you be? Well, today you're doing Lab 3, and that is due by midnight. But otherwise, you'd be in very, very good position at this point if you've got, say, the first 2 done and a good outline for the third. The third, of course, is the first 2 are relatively simple. The third one is worth half of the credit, so it's definitely more involved. But you should have a good outline for it. My suggestion would be if you're struggling at it, do it in the language, or at least outline it in the language that you're familiar with. For example, for the weather data thing, if you're coming from a Python background, do it in Python really quick and just get a solution, a step-by-step solution out on a piece of paper or in your coding environment wherever you're coming from. But otherwise, give yourself those last 2 days to make sure that you're absolutely polishing everything up, submitting it to the grader, going back to the drawing board if it's not working. For example, you might have tested it locally and it works great on that sample size of 47 points, but when you put it into the grader with tens of millions, it doesn't work, or it's not going to execute within the next couple of weeks, much less the 5 minutes that you only have the limit on the web grader. Okay. Remember that we are online, so if you have any questions, go ahead and post them to the YouTube live stream here. Otherwise, let's continue with what we were doing last time, where we were designing this book class so that we could produce a couple of reports about books. We left it off with having created this book class, made everything private, generated generated our constructor, our getters and setters, and our nicely formatted toString method, so that we could do something like this over here in the main here. We can create a book manually by providing it with a title, for author's first name, author's last name, year, and a rating here, and then we can at least print it out, right? And this will run just fine. There's our book. What I want to do now, and I've already set up a couple of things here, I want to actually load that book data from the CSV file. Remember that it looks like this. The first line has a number that tells you exactly how many lines you should be reading, and you should be reading no more. What if I just blindly go off the edge, right, and fly off the edge of the earth, right? No, I'm not a flat earther. All right, so what happens? Well, you're going to get to invalid lines here. Pay attention to that first line. Respect the first line, right? And over here in the book, then what we'll do is we'll report the best books and the worst book once we've loaded up that CSV data. We'll find a or all books by a certain author, say Frank Herbert is what I'm doing now, okay? All right, I've already set up a utility class over here, book utils. This is going to go into object-oriented programming principles. There are the solid principles. It's an acronym. S stands for single responsibility principle. What if over here in the book class, the book class is responsible for book stuff. Loading up a book is probably a different responsibility. So I've created another class over here containing a bunch of book utilities. If I had just put that in my demo class over here, right, then one class is doing more than one thing. It has more than one responsibility. Make sure that your classes have one single responsibility. Now, there is a big gray area there of, well, is this kind of related to that, or is it kind of related to that, or is it, distinct or whatever, right? Then you can start arguing about that or debating about that stuff with yourself or with your partners. But as far as putting everything into one class, that's called a God anti-pattern. You don't want to do that. You don't want to put everything into main, for example. You want to make sure that you're separating your code out into proper functions and methods, and then separating those out into proper classes. And that's what I've done over here with book utils. The other thing that I'll draw your attention to here is that every class requires documentation. Every non-trivial method requires documentation. Over here in the book class, let's go ahead and add that documentation now, right? It's very, very simple, right? It's just this class models a book, right? That's it, right? That's all you need because it's a simple data class for now. But over here in the book utilities class, again, it's a collection of utilities for book instances, right? It doesn't have to be complicated, but it does have to be there. Over here in the book class, I am not going to document the toString method or the getter methods or my constructor. Why? Because those are simple enough methods that they're self-documenting, right? Get title. It would be completely redundant if I put on a whole English sentence that says, retrieves the title and returns it, right? That's what, I mean, just read the code, right? You're done. Everybody knows what a constructor is once you know a little bit of Java. You don't need to say that this is a constructor, what takes these things and produces a book, ... right? It's a constructor, right? It's self-documenting. Right? Now, this is not self-documenting because, well, it is in a sense. It has a good name, load CSV data, right? Loads the book data from the given file name and returns a list of book instances. The file is assumed to be a CSV file in the specified format. And I'm not going to write a treatise on the actual format over here of its the title, the author's first name, author's second name, but that would be something that you might want to put into your documentation here. All right, let's start. How do we load something up from a file? Well, we need to open up that file first of all. So let me go ahead and create a file here. F is equal to new file. And if I were to hard code this, right, I would say that data/book.csv. That's not what we should be doing. We're being given a file name here, just like you're being given a file name in your Lab 3 for those who have already started. There. Now I'm going to open up that file. Now that creates a file. It does not, it creates a file reference, I should say. It does not actually open up the file yet. What is that utility that we use to read in a file? What was that called? Scanner. Right, oops, go to the next. We're going to be scanning the file. S is equal to new scanner of the file that we're going to be reading from. Need to import that as well. But remember what happens if that file does not exist. It's going to throw an exception. This is one of those checked exceptions that we're forced to surround with a try-catch statement here. To deal with that, I'm simply going to catch and release. I'm going to catch that exception. There's no way for us to recover from this file not being there, so I'm going to throw a new runtime exception wrapping around E there. Okay? Otherwise, I've opened the scanner. Before I do anything else, if you open something up, what else do you need to do? At the end, close it. S.close. There's a more modern way of doing this, a try with resources that would look something like this. Scanner S is equal to new scanner F, right? There we go. And what that will do is that'll actually close it automatically for you, and you don't need that explicit .close. If you want to explore that syntax, then go ahead and check out, say, my Computer Science 1 book, or just read a tutorial on it. It was something that was added, I believe, don't quote me, but I think it was in Java 8 or something. I'm going to go ahead and go back to this, okay? Because I actually like this a little bit better because you're explicitly closing it. Right? And at least for demonstration purposes, if you open something, you make sure to close it. Otherwise, you could corrupt that data. All right, now I want to read it line by line, starting at the top, and then read this one, process that data, and then produce books. Right? To do that, I'm going to have somewhere to put them. So let's go ahead and go back and create that. A list of book instances. What should I call this? Stuff? New array list of books. Should I call it stuff? No. Should I call it my books? Okay, that's getting a little bit better, but book is a list of books, one book. Nope. Probably do want to pluralize collections. Or what's another name for a bunch of books? Library, right? There we go. And of course, you could also call this just result and then return the result. I'm going to come down here and immediately return it to get rid of that compiler error. Okay? Now, we haven't actually processed the file yet. Now that's what the next thing we need to do. What's on that first line? The number of elements that I should be reading. So let's capture that. Int n is equal to integer.parseInt s.next line. I'm going to read that entire line, 20, and then the end line character. and I'm going to parse that as an integer so that I can grab it. Yes, you could go with s.nextInt if you want, but that is not going to go down to the next line for processing. Okay? I want to read that many lines. I could go with the solution that we demonstrated the first time with file IO, where I simply just say, while s has next line, go ahead and read that next line. String line is equal to s.next line. Right? What's the problem there? When I get past my 20 books, I'm going to go continue reading line after line after line. Does that contain valid data? No. So when we give you a hint like this, respect the hint. Okay? All right. So let's come back over here. And instead of doing a while loop, maybe what other kind of loop is there that's maybe a little bit more natural in this case? For int I equals 0, I is less than n, I plus plus. Why is that more natural? Because now up front, I know exactly how many iterations I should iterate through this thing. Okay? N. All right, grab the first line, grab the line. Now what do I do with it? Suppose that I have this thing right here. It's a CSV file. Token, comma, token, comma, token, comma, token. How did we split that up into tokens? Split. All right, line.split. Those coming from a C background. Oops. Dot, dot, dot. Well, here. I'll leave it like this. Those coming from a C background. How did we have to do this? Manually, str-toke. You'd have to write your own loop to do it, et cetera, et cetera, et cetera. Those coming from a Python background. Hopefully this looks very familiar. You have it, right? And you can split a string based on any regular expression in Python using split, right? Now that gives you a token, string tokens, right? There's my array of elements. What will that look like? That'll look like, well, the first one is going to be, for example, Harry Potter and the Deathly Hallows. The second one is going to be JK with periods there, Rowling, et cetera, right? So I'm expecting how many tokens here? 1, 2, 3, 4, 5. Right? You can do some basic error handling here by saying if tokens.length is not equal to 5, then that's certainly an error condition, right? Let's throw a new illegal legal state exception. Right? Invalid number of tokens on line. And then I'll go ahead and concatenate the line so that I know where it went wrong. We're probably not going to hit that because, of course, I do know that this is good data here. But if you wanted a sanity check, you could do some basic error handling like that. Okay? Otherwise, that first token is the title. The second token is the first name, the authors, et cetera, et cetera. Let's go ahead and create a book now. Book B is equal to new book. And I'm going to pass in tokens sub 0. That's the first name. Tokens of, or no, that's the title, excuse me. Tokens of 1, that's the first name, I believe. Tokens of 2, I think that's the last name. I'm not sure, right? You could go ahead and put these into other variables. String, title. Yes, I'm just transferring the value of that string from one variable to another variable, but now it's a little bit more readable, right? Tokens sub 0. String, for author, first name is equal to token sub 1. Right? String, author, last name is equal to token sub 2. So that I can go ahead and use those values, title, last name. Right, there we go. And let's go ahead and take a look. Are we doing that in order? Yep, first name and then last name over here in the constructor. Okay. What about those other two? That's going to be a release year, which is an integer, right? Year, and I'll just call it year here. How do I convert that string over to an integer? Just like I did up here. Integer.parseInt, right? And that's going to be token sub 3. Now, what about that last value? That's not an integer, 4.62. What is it going to be? A double rating is equal to double.parse double and tokens sub 4. All 5 of these lines, excuse me, are safe. Why? Because I did some basic error handling up here. pass all of those things in now, year and then rating. Oh, thank you. All right. Once I've got that book created, I need to put it in my library. We've got a list of books. How do I add something to a list? .append if you're a Pythoner. Right? You would have to keep track of an index and use a regular old array if you're coming from a C background. Otherwise, it's just add. Add that book. That's it. That will append it to the end of the list. Remember, a list is ordered. Now come over here to the book demo, and let's see if that was successful. Right? I'm going to create a list of books. Right? I'll call it library is equal to. I'm going to call that function that I just wrote over here, right, in the bookUtil class. Bookutils dot load CSV data. Now, in this particular case, I could load it up from one file. I could load it up from a different file. I could load it up from whatever file. The file that I'm going to open it up from is data/book.csv. But do you see how putting it into a function in a different class offloaded the ideas and offloaded the cognitive load that it would take to realize there's lots of steps in opening up and processing a CSV file, right? You're putting that somewhere else so you don't have to worry about it over here. Right? Not only that, but now it's reusable. If I've got, say, 5 different CSV files, I can load them all up, right? And I don't have to worry about rewriting that code, hard coding values like this. Right? Let's verify that it actually worked. Let's iterate over those books for book B in library and print them to the line system, just to the standard output here. Println B. There we go. Oops, and I'm going to go ahead and take this out now that I'm done testing that. There we go. There. Harry Potter and the Deathly Hallows, ... A Game of Thrones by George. Right? Looks like it works to me. In fact, if you take a look at the book, take a look at it over here, it looks fine, right? Let's test it. A canticle for Leibowitz. How do you spell it? Leibowitz, right? By Walter Miller. I think it was released in 1959, and I don't know. We'll give it a perfect. We'll give it a middling 4.3. There we go. All right. I'm going to go ahead and modify this so that now there are 21 books, and let's run it again and make sure that it still works. Hey, great. Once I've got working code and I've got at least one test case here, then that naturally leads to other test cases. We gave you a test case with 47 data points. Make your own by adding a data point. Make your own by removing a data point. It doesn't have to be that hard, right? Don't make it hard on yourself. And when we get into the project, we give you tools that's called mocking, where you can automatically generate random data, right, to represent people or customers or something like that. Right? Okay, let's come back over here to the book demo. I am reasonably sure that we are loading the data up correctly. Right? One test case is not sufficient. Right? That's why I added a book to see if it actually worked. That was basically 2 test cases. What I was doing, though, was ad hoc testing. Right? I was just testing as I went. Okay, looks good, move on. Looks good, move on. It's not repeatable. What's repeatable is in your labs. We give you JUnit tests. That's a formal unit testing framework. And what you're doing on assignment 2 exercise, or assignment 1 exercise 2. When you have to write JUnit tests, 5 each for each one of your methods in that exercise. Right? Again, it doesn't have to be hard. Just have an input, an expected output, and then call your function. Does it produce that expected output? All right, report the best and the worst book. All right. Ideas on how to go about doing this? Yeah. Okay, I could write a for loop, right? And let's say outline this, right? Iterate over the entire book collection. And if you find a worse book, update a reference, right? If you find a better book, update a reference. So we could do it all at the same time, right? And so beforehand, we would initialize and assume the first book is the worst and best. And then if you ever find anything worse, update that. If you ever find anything better, update that. Is there an even easier way? Yeah.
Is there like a, couldn't you just throw it in like a sorting algorithm similar to like
Sort the books by what?
by the double?
By rating, right? If I sorted the books by rating, where would the best one be? Up at the top. If I sorted them by rating, where would the worst one be? At the bottom. I like that idea. Why? Because it's lazy, right? Smart data structures and smart algorithms versus doing the grunt work ourselves, right? So the first thing I need to do to sort is collections.sort, my library. Is that going to work? No. Collections.sort, that knows how to sort integers. It knows how to sort strings. It knows how to sort doubles. But we don't have those things here. What do we have here? Books. So it looks at your user-defined type and says, book, I don't know anything about books other than how to create them because you wrote the constructor for me. I don't know how to compare them, right? So what's another piece of the pie that the puzzle that we need to hear? We need here a comparator for books. Right? We did this for integers already, and we did it for strings. Right? If we wanted to get a custom artificial sorting for integers, we had to create a comparator for integers to go in descending order, because the natural order was ascending order. If we wanted to compare sort strings so that Bob lowercase b and Bob uppercase b, we had to create a comparator for strings that did that custom ordering, that artificial ordering. Here, there is no natural ordering at all because it's not a built-in type. So we need to create a by rating comparator here. Is equal to new comparator for book. And I'll do it the same way that we did it with the other comparators. I will do an anonymous inline class here, and I need to spell it correctly, sorry. There we go. And once we've got it, we can provide it down here by rating. All right. Add the unimplemented methods. Remember the pattern. You're going to compare book A to book B. Right? The logic for doing that, that's where you provide your custom logic. I want to look at the first book A's rating, and I want to look at book B's rating. And I want to say that this book comes before this book if it has a higher rating. Better books, worse books, according to rating. Right? So if A.getRating is greater than B.getRating, then are they in order or out of order? One has a rating of 5 and one has a rating of 1. Right? A comes before B. They're in order because I want to go in descending order according to the rating. I return something negative. They're in order, they're out of order, or they're equal. Right? Else if, what's the other possibility? That they're out of order and A's rating is less than B's rating. In which case I would return something positive, right? 1. Otherwise, if they have exactly the same rating, this one is 4.5 and that one's 4.5. Is there any way that you should distinguish them? You could break ties by looking at the author. You could break ties by looking at the title, right? But for our purposes here, who cares? Right? A perfect five-star book will be the same as any other 5-star book. All right? Semicolon, because this is an executable statement. We've sorted them. Let's go ahead and show that it is actually sorted. I shouldn't have gotten rid of that, for book B in library, right? System.out.println B. Right? There. The best book is at the top, 4.6, according to this small data set. The worst book is at the bottom, 2.33. So I'm convinced that it works, but now let's just go ahead and pull those books out. Book, best book, is equal to, where is it going to be? At the very top, and in my library, where is it going to be? .get index 0. Right. Book, worst book, is equal to library.get. How do I get the last element? Where's that index going to be? So if I've got 5 books, the first index is at 0, 1, 2, 3, 4, right? So how do I tell the size of a collection? Library dot size. All right. Is that correct? -1, good. Remember, 0 indexing. You're always going to be off by 1. The vast majority of programming languages are like that. The few exceptions that I know of off the top of my head are going to be, don't quote me, but I think R and MATLAB. Right? Weird languages. Right? All right. Yep. All right, so best book, worst book, to do, print those out. Right. Print them out. Okay? Here's a shortcut. Here's a better way of doing it, a more modern way of doing it. I want a comparator for books, and I want it to be called by rating, but I don't want to have to write all that stuff out. Right? So what I'm going to do is I'm going to ask the class, please build me a comparator that does it by rating. So here's some modern Java for you. Comparator, I'm going to leave that in there for the notes so that you can see how to do it manually, but comparator.comparing, comparing, right? What do you want to compare? I want to compare the rating. The book class has a function called getRating. Right? One-liner, done. Right? All that's going to do is give you, I should say that the way that you read this is comparator class. Please build me a comparator comparing this function, use this function in this class. This : syntax is borrowed or stolen, I think originally from Fortran, and then C++. It is called the method selection operator. The now class, I want you to use that function over there in the book class, : use that. Let's see if this works. Now I do want to print them out, so let's get rid of that to do. System.out.println, worst is going to be plus worst book. There we go. And best is going to be best book. Let's run this and see if it comes out correct. Nope. They're switched. Why? In my artificial ordering, I went from best to worst. Right? Up here, what's the natural ordering? Worst to best, right? In ascending order. Okay, that's fine. All you have to do is chain a command, .reversed. Right. That's it. Right? You don't have to add custom logic. You don't have to flip everything. All you have to do is chain these things. Compare by getting rating, and then reverse it for me. Right? All one line. We're going to come back to this because we're going to build even more sophisticated comparators here in this last thing that we're going to do. All right? First of all, I want to find all A or all books by a certain author, say Frank Herbert. Okay? So how would I go about doing this just brute forcey kind of way? I would go through and do a linear search. For each book, right? For each book, if the author's first name is equal to Frank and the author's last name is equal to Herbert, stop, found it, done. Right? Again, that's a lot of smart code. Right? I don't want to work that hard. So ideas. No? So what's usually coupled with sorting? Searching. I'm searching here. What are the two kinds of searching do we know about? There's linear search that I just described here. Brute force. Is that it? No. Is that it? No. Is that it? Is that it? Is that it? Right? Or the other one, which is more efficient, is going to be binary search. Sort it. And then you can jump to the middle and say, is the thing I'm looking for this thing, or is the thing I'm looking for greater, in which case I search over here, or is it less and I search over here? The weird thing about this, though, is I'm searching by author. That means that I'm going to have a comparator to do that. by rating, by author. Right? So let's use the same exact kind of syntax up here. Comparing, not the rating, but let's go ahead and get rid of this. So how would you compare the authors, an author? There is another author named Herbert, his son, Brian Herbert. Is Brian and Frank, are they the same author? Nope, but they got the same last name, which is what you're comparing. So get last name, author last name, is it? Author last name. There. Nope, we always follow a lowercase, a camel casing convention, lower camel casing convention, right? That's the function name. You cannot get the author, like you can't get the title or something like that because that's a member variable. That's not a function. Instead, you would have to go with get title. That's the function that gives you the title. Right? Undo, 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 all the way back there. There we go. So are Brian and Frank the same person? Nope. So, then comparing books, get author, first name. Spell it correct. There. And reverse it if you want or whatever. All right. Now that I've got my comparator over here, let's go ahead and do it. Right? So, nope. Use binary search. Smart data structures, smart algorithms are a lot better than the other way around. And dumb code are a lot better than the other way around. So I want collections dot binary search. Binary search, you have to have your needle, your haystack, the thing that you are searching among. You need your needle, right? Frank, somehow, right? And then finally, you need a comparator to search it with. So how do we make a key in order to search for it? Right? You're searching in a library of books. You need to say that, well, this book matches this book over here. In other words, you need to compare like things. I can't just put in there like Frank Herbert. Right? That's a string. A string is not comparable to a book. A string is comparable to a string. A book is comparable to a book. Everything has to match. So I need a book key. Book key is equal to new book. All right, well, I need to create a book here. I just need to make sure that it matches Frank Herbert. Right? So what is the title? Title, question mark? Otherwise, I just go with Frank and then Herbert. Right? What about the year that it was released? This is not really a book, right? I have no idea what year it was released. I have no idea what the rating should be, right? Because I'm searching for one of those books. All I know is that I want a book by Frank Herbert. Fine. Then don't provide those things. Null. Or 0 and 0.0. Because those will be ignored in my search, right? That's kind of messy, right? What if you wanted to create a book with just the author's first name and author's last name? Right? That would be a lot simpler, right? That would be a lot less messy. Yeah. Right? Well, fine. If you want a gift, give it to yourself, right? Every Christmas I say, I want this. And of course, after you get to a certain age, people don't buy you the gifts that you want. Instead, you have to give it to yourself, right? And so if you want a piece of code that does something, write it, right? Or don't write it and let the IDE do it for you. Generate constructor using fields. Deselect all. I just want the author's first name and last name. Generate. Done. Save. Come over here, and now I don't have to be so messy in my code. If I just want the first name and last name, there's my key. Okay? Now, instead of using Frank Herbert, right, the key here. There. There's my haystack. There's my needle. And there is my criteria by which I'm searching. Int index is equal to, the way that the binary search works is it returns an index at which it finds it. Okay? So let's go ahead and go with system.out.println index is equal to index. And then also let's get that book. Frank's book is equal to library.get the element at that index. And then let's print it out. Right? Let's find what book we've got. Frank's book. Okay. Let's run this. Uh-oh. Died. What index did we find it at? Nope. -1. That's its signal for I didn't find the book that you were asking for. Wait a second. I'm pretty sure that I put all of the Dune series over here in my data set. There's one right there, Frank Herbert. Right. What went wrong? So let's refresh our memories of how binary search works. You sort it, if it's integers, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, so that you can jump to the middle and see 5. Okay, the thing I'm looking for, 42, is greater, so I go this direction, right? Then I jump into the middle again. The thing I'm searching for is less than this thing, so I focus on this half. Focus, focus, focus until it passes, right? I just started that discussion by telling you that it was sorted, right? Sorted how? Those integers are sorted in ascending order. Would it work if they were sorted in descending order? Descending order. So I'm assuming that it's in an ascending order, but it's just the opposite. Meaning that instead of going that way, I went that way, right? Or vice versa. Instead of going that way, I go that way. Say what?
So you're saying we went the wrong direction?
I went the wrong direction and I couldn't find it. Why? How is my library sorted at this point in the code on line 57? By rating. Right? If I'm going to search by author, how should it be sorted? Collections.sort by author. Library by author. Right? Your searching and sorting criteria needs to be the same. Right? Hint for this Friday, if you sort weather data by temperature, can you search for it by date? Nope. If you sort by date, can you search for it by temperature? Nope. Right? It's got to be the same. Now let's see if this works, hopefully. Hey, there we go. We found a book. In fact, it was the first book, right? 1965, Dune by Frank Herbert. Now it works. Right? So that to-do is being done. Right? To-do, find all books by a certain author, Frank Herbert. Right? So now what would you do here? What if I sorted it by author? Went down, found a book by Frank Herbert, expanded my search so that I would take everything before and everything after that was by Frank Herbert. Here are the 6 books in the Dune series by Frank, and there are your 6 books. Right? I could do that. Or I could solve an even bigger problem, right? Modify. Right? What I'm going to do is I'm going to organize, not sort, but organize books based on each author. In other words, if I had these 21 books sitting on my desk here, and I wanted you to, and I had a bunch of bins, one for each author, and I wanted you to sort them, what would you do? You'd go through and you'd say, okay, well, this book's by Frank. So we don't have a bin for Frank. What do we do? Write Frank on one of the bins and put it in there. Right? Here's a book by Miller. Right? Okay. Well, we don't have one for Miller, so I'm going to go ahead and put it in there. We find another book by Frank. Hey, we already have a bin for that. Go ahead and put it over there in that bin. At the end, what I've got is a bunch of bins where all the books have been partitioned into bins, each one of those for each author. That sounds like a smart data structure to me. The way that I'm going to do that is through a map, right? Or a dictionary, if you're familiar with those from Python. My map is going to map an author's last name initially, then we'll fix this maybe on Friday. I'm going to map an author's last name to a set of their books. Why a set? One's as good as another. It could be a list if you really wanted to, but who cares, right? In other words, what I want is something like this. Herbert is going to map to, Dune, heretics of Dune, dot, 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 right? It's going to be a set of all those books, conceptually, right? Now, if I had a whiteboard, I do have a whiteboard, but it would not show up on the live stream here. But if I had a whiteboard, this is what I would be doing. You would be whiteboarding it. You'd be spitting out ideas on a whiteboard and, well, what if we did this? What if we did this? If you're with a partner, not for assignment one, but for your project, you'd be spitting out ideas, putting them on a whiteboard, diagramming stuff, and go, nope, nope, erase that, redo stuff. That's what I'm doing right here, but without a whiteboard, okay? So that's a map. My map is going to map strings to a set of books, just like I said in plain old English there, right? And I'll call them book map. There we go. Again, there are only two difficult things in computer science. One is cache invalidation. The second is naming things. Just name it and be done. Right? Book map. Right? Is new hash map of a string to a set of books. Right? Now I am going to iterate over each book. For book B in the collection library, right? I need to outline this. If this is the first time we've seen this author, for now, last name, right? Then create a new bin or box. And in other words, box. Which is what we mean by that here is we need to create a new set, and place it into the map. Right? Otherwise, else we've seen this before. Add it to the bin, box, set, whatever you want to call it. Whatever, bin, box, that's what I would use to visualize it in real life. But when I actually go to code it, I'm talking about a set, okay? Now, how do we know if this is the first time we've seen this or not? Well, if I've been maintaining this map, which maps a string to a set of books, if this is the first time we've seen it, then I would not expect it to be in the map, right? So what I'm going to do is I'm going to create a set of books, right? Authors, books, right? And I'm going to ask the map, book map, give me everything that is by that author, right? Say Herbert. Except that I don't want it to just be for Herbert. I want it to be for this book's author's last name. So b.get author last name, right? I want to generalize it. If it helps, when you write code, as you go through a process, hard code it to something, right? Hard code it so that you have some concrete idea of it in your mind, and then go back and generalize that. Many of you are probably taking 235 right now, which is discrete mathematics. That's exactly how proofs work, right? You try it out on one example, then you realize, well, that's not a proof because it only works for that one example, and so you do generalization. All right, well, now what if we just take away that detail and make it abstract, right? That's abstract generalization or something. I forget what the term is, right? But that's how you do proofs, right? All right, so there's my author's book. If this is the first time we've seen this author, if you read the documentation for a map, then it'll be null because you've not seen it before. If author's books is equal to null, right, then the set was not in the map, right? So create it, right? Just like I said right here. Then create a new bin box, right? And place it into the map. How do I do that? I create a new book, a set of books, right? Or say author's books because I've already got that stated. Author's books is equal to new hash set. There we go. And then I will add it to the map. Book map dot add. I'm going to map this book's author's last name to this set of books, author's books. There we go. Or it's not add, sorry, it's put. Right? Add is for sets and lists. Put, because it takes two things, the key and the value. The key maps to the value. So bookmap.put, I'm going to map the last name to this set. Okay? Otherwise, we've seen it before, or we've now put it into the map. What I'm going to do is I'm going to say authors books dot add b. Here's the book. Where are you going to put it? In that bin over there. If the bin didn't exist, create it, write Frank's name on the box, and then put it into the box once it's been created. Let's take a look at what that looks like now. Dune and Dune Messiah. Right? Terry Pratchett here is mapping to Raising Steam, Mort, and Weird Sisters, and anything else, and Color of Magic. I think I only had 4. Right? I could very easily produce a report here that says, for each author, how many books do I have in their collection? Right? 4, 6, 1, right, etc. Smart data structures and dumb code are a lot better than the other way around. If I can do some, now that I've got it in this data format, and now that I've got it in this representation, I could do a lot of powerful things, right? That has me thinking, though, rethinking it. This is what we're going to do on Friday. Let's come back over here to book, right? Why did I create this book class to begin with?
Store a bunch of data.
To store a bunch of data. In other words, more than one piece of data, right? If you've got more than one piece of data, what should that be screaming out to you? Make a class, right? So if you've only got one piece of data, fine, just leave it. It's a string, it's a number, whatever. But anytime that you have 2 pieces of data, 3, 4, 5, what should you be doing? Creating a class. That has me, 1, rethinking this design. How many pieces of data is that? 2, representing one thing, an author. Maybe I should come back and rethink this and change it so that I have an author class, or a person who is an author class. Hint on your homework. The final, you can solve it however you want. We're not going to ding you on design or anything as long as it's sound and looks good. But weather data. Tell me, one weather data point, how many pieces of data is it? A timestamp and a temperature. What is that screaming out to you? Make a class. All right? Good luck.